Anything. I'm sorry. I wasn't paying. I was, but okay. If you are just watching this recording, there's the solution for number 43. Because I forgot to hit the record button. Okay, what else from your homework? 47. 47, same thing. Okay. All right, here we go. 0. Uh-oh. I have a feeling I just lost them because I heard a bloop and I'm moving faster now. Oh. Chatted me. Okay. I can't see the chats today because the internet's out on my other computer. All right. What is the equation of the first line? 0. That one's easy, right? What is the domain restriction? 0 to t over 2. From 0 to t over 2. Ah, Stacy. So t over 2. How about the next one? You put what? For your equation? All right, let's think about it. What you got? What'd you say? And what did you say, Kim? X minus t over 2? Oh, just the t is over 2. All right, here's what I would do with this one. First thing I do is try to find the slope, right? Because slope is changing y over changing x. How is y changing here? It's up 1, right? How about x? How is x changing? If you go from a half t to a whole t, how much have you increased? 1/2. A half t, right? You've gone up a half of t. So 1/2 t. I agree. So this is really right. So far, looking good, looking good. What? Go ahead. Yes. So it would be by 2, but it would be the whole thing. So the 2 would go in the top. Does that make sense or no? So if you have 1 over 1/2, this is the same thing as 1 times 2 over 1. Instead of dividing by a fraction, we multiply by the reciprocal. All right. This one's a little bit easier if you look at it. If you think about the rate of change and you think about how this is going, if this line continued, it went over half a t and up, right? So if I go over half a t and down 1, where is my intercept? -1, right? So I have, what did I say my slope was? 2 over t x minus 1. Does that make sense? Okay. Because what I did was I backwards applied the slope here. So if the slope here going up 1 and over a half t, so if I go down 1 and over a half t, I'll end up at -1. Okay. And so now I need my domain restrictions. T from t over 2 less than or equal to. Good job. Yes. Well, because it's the same point. You could leave this off for one of them, but the output's still going to be the same. You see what I'm saying? So you'd still have, for that particular input, you'd still have the same output. So you could leave it on or off. Right. Correct. That's everybody okay? All right. What else? Margaret, which one did you say? 31.
Good morning, board.
All right, 31. This one we are graphing. F of x equals 3 minus x and 2x. This one is for x is less than or equal 1. This one is for 1 is less than x, which is the same thing as x is greater than 1. I don't know why they would write it like that, but whatever. All right, so 3 minus x. I'm not even going to try to change color. Nope, changed my mind. Stop. I just use green. Green is good. Green's fine. Okay. And I'm just do for God again. It's just habit. It's just habit. All right. I'm just gonna do first quadrant because I'm gonna. That's all I'm gonna be in right now. So I have a y-intercept of 3. Actually, no, Stacy, stop. This is piecewise. If this is my line, but my domain is restricted smaller than 1, okay, what happens at 1? What is the point on that line when x is 1? It's a closed dot, and it's 1 what? What's the y-coordinate? 2. Do we all agree that included in the domain restriction is the 1, 2 closed dot? It's my starting point, so to speak. Okay. 1, 2. Now it goes smaller than x, so it goes to the left, right? And what's the slope? -1. As I'm going to the left,
I still don't understand.
You don't understand what?
I don't understand what you got that.
So look at your restriction, right? My restriction is at 1. So what I did was I plugged restriction in here. So if you plug 1 in for x, if I can write, you got 3 minus 1, which is 2. So that's where, oh, this is ridiculous. That's where this point came from. 1, 2. Then what I need is I know that it goes in the direction that x gets smaller. So what's smaller than 1? You could do 0 and plug it in. If it's easier for you to plug in, what I did was I said I know the slope is -1, so I made this have a slope negative. But you can plug in 0 here and say, okay, well, 3 minus 0 is 3. So 0, 3, point off, 0, 3. So if I follow that same thought process and I plug, whenever I look at this equation, if I plug in 1, what's your output? What do you get if you plug in 1? 2. This time it's an O dot, and it really doesn't matter because this is the same point, right? But this line is going to go bigger than x, right? Slope is 2, which means go up 1, 2, and over 1. Does that make sense? Mary Margaret? No? Which part does not make sense? Do you see how we plugged in the... Do you see how we plugged in this initial point? Okay, so after you plug in that initial point, look at what it's telling you to do. It's telling you on this first one that x is less than 1. So pick a number that's less than 1. 0. And plug that one in also. And that'll give you your 2 points. This one, the same thing, only you need one that's bigger than 1. So pick maybe 2. And plug that one in again to this equation. It's kind of awkward whenever we're going between computer and class. I will. Oh, 56 a do. What did you do? Look at the words and go, no.
I attempted.
Okay.
I got 144,000.
The answer, something, let me see. I did. I don't know what the answer is actually. Okay, let's see. Industrial loss. Eaton Power and Light Incorporated has a power plant on the Miami River where the river is 800 feet wide. This is a river. That's a river. Okay. To lay a new cable from the plant to a location in the city 2 miles downstream on the opposite side. All right, so this is my power plant. 800 feet, 2 miles. $180 per across the river and $100 per foot across the land. Suppose that a cable goes from the plant to a point Q on the opposite side, the plant to a point Q on the opposite side. That is X feet from the point P that is directly across from the power. Good Lord. Okay, here's point P directly across from the power plant. Here's the point Q. This is, what did it say? X. Do I have it drawn correctly? But it says it's 180 feet, $180 per foot across the river and $100 per foot along the land. Oh, so we got to find, so this one is $180 per foot, right? Y'all, across the river. I have about 2 people that are even following what's going on, and I'm because thank you. You know, it's not supposed to shut. It's not supposed to stay locked. People just shut it and lock it. So I'm sorry. And then this one. All right. So here's what we got to do. We're gonna have to look at this as a right triangle. Okay. We're gonna use Pythagorean theorem. There is, but that's okay because in our cost, function is going to have an unknown in it. Okay, so here's what we want to do. I am going to convert miles first to feet because I want all my units to be the same. How many feet are in a mile? 5,280. Job. Yes, we got some. Okay, so this is 10,560 feet. So this white length is 10,560 minus x. Are y'all with me on that? Okay, look, I'm going to have to find, to solve this problem, I'm going to need to find this, $180 per foot. Oh, yes. Okay. And I'm going to need to find this. Because this one is going to be $100 per foot. Okay. So, let's find the length of the hypotenuse, and we're going to do it in terms of x, and that is okay. Right? Okay. Let's call this, we'll just call it C right now. So we know that 800 squared plus x squared equals C squared. So what is the length of the hypotenuse? Y'all can do this. What's the length of C? It's okay to vary on it.
Yo, no.
That's not it at all.
Okay. We can square root both of them.
Square root, Joseph. You're supposed to be good at that, remember?
Yeah.
You're square root people.
Yep.
Okay. This side, look, leave it like that. Leave it like that. The length of this side is the square root of, if you want to multiply out 800 times 800, be my guest, I'm going to keep it as 800 squared plus x squared, but you got to have that radical on
You
it.
can't just like, since they're both straight, can you just make that 800 plus x? That was multiplication.
No, if it was multiplication, yes, but because you're addition, no. Same reason you just that squared through when you're adding in there. So now, this looks way worse, and the wording was so convoluted. This is a hard problem when you dig down into it. I promise. Because watch what we're fixing to do. All it asked me is for a function c of x, which means a way that I can plug in the length of x and find the total, okay? So here's what I'm going to do. Remember, if I know the cost, right, the length, I have to multiply cost times length, and just add them together, right? There's only one variable in there, so it says c of x. Write a function c of x. I think the picture was the hardest part to get down. Or my pen. All right, let's look at that hypotenuse. The cost is 180, right? And I'm going to multiply that by this length of c, the square root of 800 squared, like that's a squared, plus x squared. And to that, I need to add the length of what? The 100 times for the land up there, right? So 100. You probably thought it was not okay. Leave this way. Come on. Or did you get this far? Did y'all get this far?
No. I was confused. I said to plug in.
Times 10, 5, 6, O minus x. Good Lord, there's my function. Is it really? Oh, I was going to get so excited. All right, how B, generate a table of values. Generate a table of values. I would probably do this on the calculator. To determine if the least expensive location for point Q is less than 2,000 feet or greater than 2,000 feet from point P. So I would just put that, do y'all need me to do that part on the calculator and show the table? I would do that on the calculator and go into your table and type the values in and see which one's bigger. This was definitely harder for that. Y'all are bored, I can tell. Extremely, Corbin, I'm sorry.
My brain.
I had to through that a little bit by myself.
Can we do 66?
All right, let me do 53, then I'll do 66. That was said with such. 66. Did y'all forget how to do function composition? Is that the problem? Because that's what 66 is to.
The fraction that you did for the function composition is 6x plus 2 over 4 minus 2x minus 1 over 3x plus 1 over 2x.
Why are there so many overs?
Oh, yeah, because it's both.
51 and 52 is
I wonder if it'd be great if I
Well, it's not responding yet, do it.
No, it's definitely got me slower.
Yeah. It's almost impossible to work these kind of, and I was gonna get a one of those drawing books you can, but then that's gonna be more equipment for it to.
Yeah, 'cause they usually have their own, like, drivers that has to be running as well.
That's too much for these things. All right, so if f of x is the square root of x minus 5, and when you compose the functions, you get the square root x squared minus 5. What do you suppose g of x is? X squared. The other ones are what was hard? One plus 1 over x. Y'all, would it be easier if I made the lesson videos ahead of time for you to watch at night?
I ain't got a ton to watch every 4 years. Watch Miss Twitty's videos. I'm sure you can find her videos.
Don't play with her, Joseph. All right, so if f of x is 1 plus 1 over x, and f of g of x is just x, what do you suppose g of x could be? Let's see. 1 over x. So what everybody got? Minus 1. If we did f of, if we plug that in, the x would go away that way. Because now I have 6 classes texting me. All right, what else? What you think? Yeah. Oh. But it might work. I think. Does it work? Why? It's not the stylus, it's the software. But, yeah. Yeah. But it's the best. I had, that first day I tried to use that Miro software, but when you do something like that, and you have to record, it bogs it down even more trying to pull from the internet. What'd you say? 1 over x minus 1. Does that work? F of g of x. So if I put that in here, yes, that does work. That does work. Nice job. All right. How about 1 over x is g? I would start thinking about things like that, like how could I get the x to the top? And I know I'm going to have to get the 1. So that's, and then it's a trial and error kind of thing. Yeah, tell us how you did it. Show us how you did it.
What I did was to 1 plus 1 over g of x is equal to x. And then I did 1 over u equals x minus 1 because I had to move the 1 from the left to the right.
Mm-hmm.
And then I multiplied everything on the side g. So it was 1 equals xg minus g. And then I moved everything up and... Can she write this on the board? Yeah, I know.
Yeah, sure.
Yeah. That's
like 15 minutes.
Is that all we have left?
Yeah.
18.
Okay.
Wait, but
Wait, hold the phone. 18.
What?
Number 18?
No, we have 18 minutes left in class, and we have to start your work.
Oh my god.
Oh, the square root of x one? Square root of x. Oh. Don't worry about that one. Don't worry about that one. Your f's gonna have an absolute value in it and a squared, but. All right. Are y'all okay now? Remember, these are still the prerequisites, so.
that's what scares me.
Well, the concepts themselves are easy, but taking them to a whole new level. Like, you've never composed functions, but you haven't gone backwards to find functions from a composition.
I've never done that.
All right, so let's talk about exponentials real quick. Y'all, somebody give me a heads up. It's like 2 minutes before the bell's going to ring. Okay, by the time I write the heading, that's when it will be, because all right, exponential functions. Do you remember decay? I hope you did, because I hope y'all hit that in pre-cal. I know we had it in algebra 2, but I hope you hit it in pre-cal in terms of, go ahead, Courtney. Hopefully the focus in pre-cal was on it being the inverse of log functions, and you moved into log functions. Okay, let's talk about exponential functions then. All right, so exponential functions are in the form of a times just our basic graphing function, all right? You do remember seeing this? All right, and so if b was our base, and it's never, never, never negative. If it's negative, that means the a in front is negative, okay? B never negative. So if b is less than 0, is a d. Not, so, right. Oh, less than 1, I'm sorry. Golly. I'm sorry. I'm so focused on this stupid thing not writing. I don't have any excuse for putting less than 0. Because you're right, it could be less than 1. I know, and you said, like, 0.2, 0.3, and I'm like, yep, that's exactly right. Which are all bigger than 0, not less than 0. I need to refund my math degree, apparently. Okay, come on. All right, D, A. So these are the ones that have an asymptote. The parent graph asymptote at 0, and decay comes down and hugs that asymptote that way. Remember this now? So the parent function, remember, we can shift up and down by adding or subtracting numbers on the end, or left and right by adding and subtracting numbers to the x. But the parent graph has an asymptote on the x-axis. And decay comes down and hugs that asymptote.
So go out to the y.
Yep. So growth is when b is greater than 1. This is a nice even curve if my pen would work. Just quickly, and I wanted us to do this together just out loud, but don't take your book out. I'm just going to tell you the equation. Things that make, I should have put growth here. Growth. No. X-axis. It's not. It's not a. But if you have 1 to any power, it's still 1. So it's going to be just a horizontal line. Yeah. All right. Things that make it look like something it's not. In other words, maybe my b looks like it's 3. Maybe I have y equals 3 to the negative x. What is a here? A is 1. What is b? No. Yes. So yes. Why is it 1/3? That negative exponent is going to flip that around. That negative going with the x is going with the b there. It's going to flip it around. So really, this is the same thing as 1/3 to the x. So it is a decay. Okay. Watch out for those kind of things. No. Okay.
It can never be negative when it's in the heading.
Not like when it's written this way. No, it's flipping that base around, causing it to be decay. To the x. To the x. How about this one? You tell me growth or decay. And was it different from the parent graph? It's growth. This one's growth because 1/2, that negative exponent flips around, so it's a base of 2. Okay? So it is a growth, but what's different about this one? It's reflected. It's flipped over the x-axis, so it's going to become... What? No, it's still negative. Well, the base is never negative. So A is -1 here. And that... So this is what it's going to look like. It's a growth. All right, so think about what a growth looks like. It's going like this, but this time it's going to be flipped. The exponent's not flipping it, the A in front is flipping it. Because it's negative. Two.
Can you write out what it'd be like?
You don't really you leave it written like this, but you have to interpret it to be
Y equals to the x.
right.
There's a negative in
Yeah,
front of
A.
it.
For this one, I don't know if y'all remember when we did this in class, but I used to make y'all write what is A, what is B, what is H, what is K, every single time so you recognize. But if it's near, you have to realize it's not, it is there. It's just a 1. Yes, Colby.
What is the math behind the fraction rule?
How are you? It's good. Yes, I got it. Thank you. Why is the what? Because negative exponents flip things around to positive. Remember that exponent property? X to the -1 becomes 1 over x. It flip it and becomes positive.
Maybe 1 over x to the 4.
Right. Say it again.
If it was x to the -4th, would it be 1 over x to the 4th or 4?
This was -4x right here.
I'm like, this is the basic one that you do.
It'd be 1 over x to the 4th. Yes. Yes.
How would you flip it over the y?
That's what the A is.
That's what the, why does it not?
Like how would you, what would you have to do for that?
You would have to, yes, you have to negate the x with a parenthesis up there so that it's stuck just with the x there.
Doesn't have to be parentheses negative x. They equal what
Because remember, negating x reflects over y and negating y reflects over x. Y'all okay? Okay. All right, growth, decay. Listen, if I gave like 6 equations and 6 graphs and they were all exponential growth and decay, could you match them up quickly doing them on your own? Like, hey, I know this is a growth. I know this is a decay. I know this one is, I know this one up. I know this one is going down. I know this one's shifted. 1. Everybody good on that? Okay. All right, just making sure.
Just because it's flipped over like that would still be that would be growth.
It's still a growth, yes. It's just a growth that's reflected over. Everybody? Okay. Let's talk about, should we talk about money first? Or, let's talk about half-life. Do y'all remember doing half-life?
Yes. AP 10.
Oh. Ours is probably going to be not as involved as y'all. What time is it?
It's 9:23.
We won't pass the AP exam. The AP exam.
Let's do this.
I think I am.
I'm going to give you these formulas, Glee, okay? And I know you might have some questions on a couple of the parts from the homework, but these are usually really easy for students. Do you remember let's skip over half-lives for just right now and we'll come to it, but let's talk money for just a second. And interest. You remember this? So, yes. Two different formulas for use as we talk about interest, okay? We can be compounded two different ways. Be compounded continuously. Please just work and let me get this done. Those two last formulas. Compounded. It is, look. Oh. Compounded continuously. That's compound cent. Compounded continuously versus compounded a certain number of times per year. So the continuously is always the easiest one. So you use that PERT formula. Do y'all remember PERT? P is your initial amount. What? Yep, that's exactly right. E, y'all remember E, right? Big in our exponents. And T. R is your rate as a decimal, interest rate is a decimal. T is your number of years or your time, whatever your time period is in. That's the number of times that it's,
Are you raising
you're raising E to R times T. So you have this on your notes because my pen is so laggy. P is initial amount. Okay. R is rate as a decimal. And T is your time. Okay. E is E on the calculator. It's that irrational number E. Okay. This is so if your interest is compounded continuously at a rate of 2.7%, then it would be 0.027.
What does R and T mean?
R is the rate as a decimal. T is the time. It would say how much money do you have if you deposit $500 in your account compounded continuously for 10 years at a rate of 2.7%, how much money will you have? So T would be 10 after 10 years. The other one is a little bit harder, and you're going to have to work with a little more. A is your initial amount here. This is if it's compounded a certain number of times per year. That's N. Okay, so no, this is compounded a certain number of times per year. Write that on your notes. I'm sorry, it's lagging so bad. I don't have time to write more than like a couple letters.
Let me ask you a question.
Yeah.
You see how you like wrote money and interest?
Mm-hmm.
Are those, is there this for just money, this for interest?
No, that was the heading.
Okay.
So when you talk about interest, you could be compounded continuously or you could be compounded a certain number of times per year. If it's a certain number of times per year, let's say they told you you deposit $500 in your account, interest is compounded quarterly, how much do you have at a 2.7% interest rate? That would be the bottom formula, okay? So N is the number of times it's compounded per year. Quarterly would be, weekly would be 52. Monthly would be, daily would be, and the bigger that number gets, the closer you get to that PERT formula. A is your initial amount.
Okay, it's a one, correct?
That's a 1. So here's what you're going to be doing with that. You're going to take things, probably say, let's say you take $200 and it gives you this whole scenario. How long will it take you to quadruple your money? Okay, so you'd have to figure out what is quadruple my money and set this equation equal to that and solve from there. Okay, use your calculator. We're going to talk about logs next week. You really need logs to solve unknown exponents. But for right now, use your calculator, and y'all have learned solve by graphing in pre-cal, right? Where you graph one side of the equation and you graph the other side of the equation, and their intersection is the solution. So a linear on one side, an exponential on the other side, where they intersect is the solution.
It really helped
Wait,
when I
what
said to
is,
you
so the
about.
n